Hey guys, how's it going? We're back with some sample problems from 2.12.2 review. So let's take a look at them. The first part here is no calculator. So it says for problems 1 through 7, let the position of the particle moving along the x-axis be given as this. So we have a position equation there. X of t is measured in meters and t is measured in seconds. The equation x of t is defined for 0 is less than or equal to t is less than or equal to 10 seconds. Okay, so the first question is find the equation for the instantaneous velocity at time t. So the velocity equation for the general equation for at any time t, we need to know that we need to derive the position equation to get velocity equation. So doing the derivative here, by the way, when you do this, it's important to label it, right? Instead of just writing 3t squared minus 24t plus 45, right? That's not an equation, that's an expression. We want to write this as v of t equals. Okay? Just as a heads up here, on a lot of these problems, you use information from previous problems. Right? It can help you and save you time in the future. It's only going to help you if you label it well. Okay, so that's our velocity equation. Our acceleration equation, we need to do the derivative of velocity. So a of t, that should be 6t minus 24. So pretty simple process to move from position equation to velocity equation to acceleration equation. Just make sure you're doing the derivative. The question 3 here has some vocab that's important to know. I asked, what is the initial velocity of the particle? Initial means at the beginning time. Our beginning time we know is t equals 0. Right? So our initial time is at t equals 0. I want to know the velocity at t equals 0. So I'm going to write that as v of 0 equals, right? And now I'm going to use this equation up here. So it's going to be 3 times 0 squared minus 24 times 0. I know those are both 0, so I'm going to get 45. My units here, since x of t is in meters and t is in seconds, my velocity would be in meters per second. I didn't specifically ask for the units there, but I think I meant to do that. Okay, we want the acceleration at time t equals 9. All right, now I'm just going to plug 9 in for t in my acceleration equation. A of 9 then would be 6 times 9 minus 24. That's 54 minus 24. That is 30. Again, my unit for acceleration would be meters per square. Question 5 says, at what time or times in the interval 0 to 10 is the particle at rest? Okay, this is again one of the definitions from the Quizlet. Particle is at rest when v of t equals 0. So I want to take my v of t equation and set it equal to 0 and solve. Again, this is why it helps to have v of t labeled up here, right? So we make sure we can quickly and accurately grab the v of t equation. I'm not plugging in 0 for t, I'm setting the whole equation equal to 0 and solving for t. So I want to do 3t squared minus 24t plus 45 equals 0. The first thing I notice here is that all of the numbers here are divisible by 3. So I'm going to make my life easier and divide everything by 3. Doing so gives me t squared minus 8t plus 15. So now I need to think of two numbers that multiply to make positive 15, but add to make negative 8. And since my leading coefficient is a 1 here, once I know those two numbers, I can go straight to my two binomials, right? The two numbers are negative 3 and negative 5, because negative 3 times negative 5 is 15. Negative 3 plus negative 5 is negative 8. I can go straight to t minus 3, t minus 5 equals 0. I get two solutions. T equals 3 and t equals 5 seconds. One thing to make sure any t-values you get are actually on the interval given. Right, 3 and 5 are both on the interval 0 to 10, so they both count. 6 says, during what intervals on 0, 10 is the particle traveling to the right? Well, what I need to know, again, this is from the Quizlet definitions, we know going right is when v of t is positive. So what I need to do here is make a v of t number line and test this thing. Okay, so I'm going to make my v of t number line, and I'm going to label it v of t, because again, that could be helpful. So I know 0 and 10 are the bounds on my interval, and now I'm just going to go ahead and plot the two zeros I got from question 5, which would be at t equals 3 and t equals 5. Again, I know my velocities there are 0 because I just solved that equation setting it equal to 0. Now what I want to do is test numbers in between these zeros. So I'm going to first pick a number between 0 and 3, right? And I can include 0 here. In fact, if you look up to question 3, I already found v of 0 was 45. So I already know that that first region is positive. Okay? Or we can plug it into this factored form here of t minus 3, t minus 5. Right, if I plug in the number 0, I'm going to get a negative number here and a negative number here. A negative times a negative is a positive. Now I need to check a number between 3 and 5. I'm going to choose 4. 4 minus 3 then becomes a positive number. And 4 minus 5 is a negative number. A positive times a negative is a negative. Then I'm going to check a number between 5 and 10. I'll use 6. 6 minus 3 is positive. 6 minus 5 is positive. A positive times a positive is a positive. This sign chart is very helpful because now I know all the times when v of t is plus. And I'd make the same sign chart if the question was about traveling to the left. But it's about traveling to the right. So now I'm going to report my interval as I'm traveling to the right on 0, 3, union 5, 10. And my explanation or my justification, okay, here's where in our justifications we need to get very specific. We want to say, because that's when v of t is greater than 0. Okay. Remember, make sure you reference v of t and not say that's where it's positive. Okay. Question 7 said at t equals 2, is the speed of the particle increasing or decreasing? Okay. To determine where speed is increasing or decreasing, another way of phrasing that is speeding up or slowing down, I need to consider the velocity at 2 and the acceleration at 2. I need to check the signs of both of those. If the signs are the same, then the speed is increasing. If the signs are different, then the speed is decreasing. And when I justify that or explain that, I need to be very specific on that. Okay. Now, here's where a nice, well-labeled sign chart is helpful. Looking at my sign chart in question 6, I can tell that v of 2 is positive. This saves me time. Okay, if you're going to use your sign chart, you need to make sure that you did your sign chart correctly. Right? If you mess up your sign chart and then you use it, then that's going to cause a bad ripple effect. Okay? So I know v of 2 is positive. A of 2 then, I'm just going to plug into the equation. So I don't have an A sign chart. So I'm going to plug A of 2 into my equation. And that's going to be what? 6 times 2 minus 24. 12 minus 24 is most definitely a negative number. So I can say the speed is decreasing. And I know the speed is decreasing at t equals 2 because v of 2 and a of 2 are opposite signs. And that wraps up that section of problems. Okay? But again, lots of definitions you need to know. You need to know how to tell if speed is increasing or decreasing. You need to know how to tell your direction. You need to know when something is at rest, right? All those things use the Quizlet to help you. Okay, the next question. I give a puppy's velocity here, and I said its velocity is given by v of t equals this equation, and I want to find the times when the puppy changes directions. Okay, we have to know that change directions means v of t changes signs. That is the definition. So v of t, right, candidates for changing sign would be our zeros. So by looking at this equation, since it's already factored, I can just set each binomial equal to 0 and solve. By doing so, I get solutions, right? I know v of t equals 0. Right, when t minus 3 equals 0, it's going to be when t equals 3. 2t minus 10 equals 0, that'll give me a solution of 5. T minus 8 will give me a solution of 8. T minus 11 squared, right? We can do the square root with 0. We get 11. So those are the ones I want to test. I should have had on here, this is for t greater than or equal to 0. So I'm going to plot those zeros, 3, 5, 8, and 11. And again, I'm doing this sign test for velocity. I know my velocity is 0 at these 4 spots. So I want to pick a number to the left of 3. So I'm going to pick the number 0, right? Or you can pick the number 1, right? Just to mix it up, let's try 1. What I'm going to do now is I'm going to keep track of signs on top of this equation, right? So let's use t equals 1. So plugging in, 1 minus 3 is most definitely a negative number. 2 times 1 minus 10 is definitely a negative number. 1 minus 8 is negative 7. That's a negative number. Here's where we need to be careful. Pay attention to that little squared sign. When I plug in 1 for t minus 11, I get negative 10. But negative 10 is a positive number. Negative 10 squared is a positive number. Right? And in fact, any number squared is a positive number. So as long as I choose a number that's not 11, I'm going to always end up with a positive number there. So I'm going to make a note to myself, always plus. Okay? So now I can do a negative times a negative, which is a positive times a negative, right? So negative times negative is positive, times negative is negative, times positive is still negative. Now people can confuse themselves doing that. An easy way to, if I'm multiplying numbers here, if I have an odd number of negative signs, the overall sign is going to be negative. Since I have 3 negatives, right, and I'm multiplying them all together times a positive, that overall sign is going to be negative. All right, now I'm going to pick a number between 3 and 5. I'm going to use the number 4. 4 minus 3 now changes to a positive number. 2 times 4 minus 10 is still negative. 4 minus 8 is still negative. 4 minus 11 squared, that one's always positive. Now when I look, I have an even number of negative signs, so I know my overall sign is plus. I'm going to choose 6. 6 minus 3 is positive still. 2 times 6 minus 10, now that one changed to positive. 6 minus 8 is still negative. 6 minus 11 squared is always positive. And I have an odd number of negative signs now, so my overall sign is negative. Now I'm going to choose a number between 8 and 11. I'll choose 10. 10 minus 3 is positive. 2 times 10 minus 10 is positive. 10 minus 8 now changes to plus. And the fourth one is always plus. When I multiply 4 positives together, obviously that's going to come out positive. Now I'm going to choose a number bigger than 11. So I'll use 12. And I can see they all stay positive. 12 minus 3 is positive. 2 times 12 minus 10 is positive. 12 minus 8 is positive. 12 minus 11 squared is positive. So again, these 4 numbers were candidates for changing directions, but not all 4 of the numbers actually had a change of directions. Okay, let's look at the first one, t equals 3. The velocity did change signs from negative to positive, so t equals 3 is one of my solutions. I also changed signs at 5. And I changed signs at 8. However, my velocity did not change signs at 11. Therefore, that's not one of my solutions. My justification? That's when v of t changes sign. V of t did not change, even though v of t was equal to 0 at 11, v of t did not change sign there. Make sure in your justifications you're actually referencing v of t, not saying that's where it changes signs. All right, next one. This next one is all calculator. So what I'm going to do is I'm going to call up my calculator here. And I always like to do all my calculator problems through the graph. So the first thing I want to do is I want to graph this function, and then I want to set my window to be between 0 and 8. So let's call up my graphing calculator here. This takes a second to do. Okay. And I'm going to graph that function, and I need to make note that this is a v of t function. This is my velocity function. Okay, so I'm going to go to my graphing calculator here. I'm going to go to my y equals. I'm going to go ahead and graph that function. So it's 1 plus I have a fraction here. It's cosine of 2t. I'm using x instead of t over e to the negative 0.2t. Okay. You want to make sure that you type this in correctly. Again, if you're ever doing things with negatives, make sure you're using this little negative button down here. Just want to double check to make sure that's my function. Okay. And again, these things can take a while to graph on your calculator. It makes sense to set your window first. So I want my window to be between 0 and 8. I like to have my y min and max. I don't know. I usually use a default of -5 and 5. And I need to make sure my calculator is in radians, which it is. Now I can hit graph to see what this thing looks like. And again, this graph that I'm seeing right here is my velocity. It's important to keep that in mind. Okay, so there we have it. Okay. Now the cool thing about this is I can evaluate my velocity at any point in time by tracing that. I can find acceleration at any point in time by doing second calc dy dx, right? I can find intersections, I can find zeros. There's just lots of stuff I can do through the graph. So let's go back to the questions. First question is, what is the velocity at t equals 3? So again, I'm looking for v of 3. Now, here's where it's important to understand that, okay, I have a velocity equation. So v of 3, I just want to trace the value of 3 on my velocity graph. So I'll go back to my calculator, and I'm just going to hit trace and the number 3. And my velocity will be this y number right here. Now I could write this as 2.749 or 2.750. Just make sure there are a total of 3 decimal places. There's no units that I need to worry about, so I don't write any. Okay? If I want a velocity at a different time, right, I can just trace a different number. Now I want the acceleration at time t equals 1. Well, what we need to know here is to get acceleration from velocity equation, I have to do the derivative. So I know a of 1 is going to be the same as the derivative of velocity at 1. Okay? So I'm going to go ahead and do the derivative of velocity at 1. Right, I can do that by doing second trace. And number 6 here is dy dx. That's where we do derivatives, obviously. And then I'm just going to type in the number I want to do the derivative at. And then just look for dy dx equals. This is my answer right here. So a of 1 is negative 2.323. Again, so I can find accelerations at any times I want. I don't have to do a quotient rule, chain rule hybrid here, right? Numerical derivatives are very quick and easy to do on your calculator. All right, question 3. At what times on the interval 0 to 8 did the particle change directions? Again, that's where our definitions come in. I know we change directions when v of t changes sign. I know that v of t is going to change sign at the number 0, or could change the sign at the number 0. So I'm looking for the zeros of v of t, right, which I have a v of t graph. So I'm just going to look for the zeros, and I'm only going to report numbers where the sign of v of t actually changes, right? It has to be a 0 where we actually cross the t axis. So when I'm looking at my graph here, again, I think my window stayed the same, yeah, 0 to 8. So I'm looking for the zeros where I change sign. Now, by looking at this graph, it's obvious to me that 1, 2, 3, 4, 5, these 5 zeros, v of t changed signs. However, if my window was zoomed out a little bit, or sometimes on the black and white calculators, right, if I had this like negative 20 to 20, it's a little bit harder to see if we actually change signs at those zeros. Right, when we're zoomed out, it's kind of hard to tell if we're actually changing sign. Right, so I want to make sure that my y min and max are small enough so it's really easy to tell. So I'll go back to my negative 5 to 5 here. So if you're having trouble seeing that, adjusting your y window can be a smart move. Okay, so now what I want to do is do second calc. I want to find these zeros because I need to report them all. Now, when we find these zeros, it's going to ask us for a left bound and a right bound. We have to find each individual one on their own. Okay? Now, you can arrow the keys over, but that can be a little bit slow. Okay? If I'm going to look for this 0, I can use 1 as a left bound. And I don't want to use 2 as a right bound because I don't know if this 0 occurs before 2 or after 2. So I'm going to use like 1.5 for my right bound. If you don't like it that way, you can definitely use the cursor. It's just a little bit slower. Okay, and I just want to make sure I only have 1 0 in between, and I'll hit enter. So here's my first one, 1.234. But I know that there's going to be 4 more. So I'll get my next 0, second trace 0. And now I'll do 1.5 for my left bound, and I'll do 3 for my right bound. I never do the guess thing. I just hit enter. And my next zero is at 1.988. And again, I'm only reporting these zeros because I can see that the velocity does change sign there. Just keep that in mind. Okay, next zero. I got 3 more to go. Let's do it quick. So I'm going to use 3 as my left bound, and I'm going to use 5 as my right bound. And my next one is at 4.152. Okay, I'll do second calc 0 for my next one. I'll use 4 as my left bound. Oops, that was a bad one. 6 is my right bound. So I made a mistake here, but you can see there are 2 zeros in between, right? And it happened to choose the right one, but you just got to be careful when you do that. That was a mistake on my part. But it found the zero I was looking for, which is 5.322. And my last one I want the zero that's between 7 and 8. And that's 7.188. And again, my explanation or my justification is that is when V of t changes sign. Okay. The next question, I'm going to try and speed it up here so we can end this video sooner. How many times on the interval 3 to 5 did the particle have a speed of 1? Okay, when we say speed of 1, that word speed needs to set off some alarm bells in your head. A speed of 1 could be a velocity of positive 1 or a velocity of negative 1, because speed is the absolute value of velocity. The other thing you need to take note of here is I changed the window to 3 to 5. So let's go back and adjust our window to be between 3 and 5 for t, which is x on my calculator. And then I want to go ahead and graph both positive 1 and negative 1. And I'm looking for intersections between my velocity and these 2 horizontal lines. Okay, it's graphing pretty slow. Okay, there's one place with a speed of 1, and there goes the second place, and no third place. Okay. So what I need to do is I need to find the time right here and the time right here. I'm going to find that by using intersect. So I'm already close to my first intersection on my first curve, so I'll hit enter here. That's close enough. I'll hit enter here and enter one more time. So my first time is 3.927. I need to find that other intersection. I'll do second calc number 5 intersect. And now I just want to arrow over to be closer to that second intersection. Okay, close enough. I'll hit enter. Now it's wanting me to use this line, but I don't want that line, so I have to hit the down arrow. That's the line I want. I'll hit enter and enter one more time. And I get my second solution of t equals 4.414. Okay, so how many times did we have a speed? Let's make sure we answer that 2 times. at t equals 5, is the particle speed increasing or decreasing? Well, we've already answered a question like this. We know that we need to check v of 5 and a of 5. Those are the two things we need. And we need to compare their signs. Well, for problems 1 and 2, we know how to do that, right? So I'll go to my calculator to check v of 5. By the way, now I can stretch my window out a little bit. I just need to include 5. Okay. I'm also going to now get rid of these other two lines because they're kind of messing with my head. I'll delete them. Okay, and now I can trace 5 to figure out the v of 5. Every time you switch windows, it has to regraph it, so I can take a little bit of time. So I want to trace 5 for v of 5. And v of 5 is negative 1.281. But I'm mostly concerned that that's a negative number. A of 5 then, I'm going to do the derivative at 5. I'll do second calc 6 for dy dx. And I want to do that at 5. And my dy dx is 2.501. Which I know is greater than 0. So I can say the speed is decreasing. Because, I should say at t equals 5. Because v of 5 and a of 5 are opposite signs. Okay, the last question here says on the interval 0 to 4, during what intervals is the particle moving left? So I'm going to go back here and change my window to 0 to 4. And I'm looking for when this thing is moving left. Well, I know something moves left when the velocity is negative. And I can tell I have a negative velocity in that little stretch. And never again, okay? Now, you can go back and find these zeros, but we already found both of those zeros, okay? So I'm just going to scroll up and look. Okay, I want a 0 that's between 1 and 2 and a 0 that's around 2, okay? No sense reinventing the wheel here. These two zeros that I'm looking for. And it's between them that my velocity was negative. So I'm going to say 1.234, comma 1.988. Depending on the justification, v of t is negative there. All right, I'm just going to buzz really quickly through these last ones because we're running out of time. Okay, on a velocity time graph like this, okay? If they want the velocity, we can just read it, right? V of 6 is 0.3, right? Units would be feet per second. Traveling to the right would be when velocity is positive. So we'd say from 0 to 2, union 5 to 12, because that's where v of t is positive. Now, when they ask questions about, like in C, they asked about what time did this person turn around to go home? Turn around to go home is changing directions. We change directions when velocity changes sign. Okay? Right here at t equals 2 is where the velocity changed from positive to negative. That's where the person turned around to go home. So C would be t equals 2. Acceleration, right? We have to do the derivative of velocity. Well, since we have a velocity time graph, the derivative is going to be the slope. I want the slope at 11.5. the slope of that line will be, it goes down 0.2, so negative 0.2 over 1, so negative 0.2 unit feet per second squared. And speeding up or slowing down at t equals 3.5, I need to compare v of 3.5 and a of 3.5. v of 3.5 is negative 0.1, so my velocity is negative. A of 3.5 will be this slope. That's a positive slope. Since velocity is negative and acceleration is positive, we're slowing down at that time. Okay, that's it for today. Sorry this video got kind of long, but hopefully it's helpful to make sure we pass tomorrow. See you guys tomorrow. Good luck studying. 2 chains. Bye.